What this says, find the equation of the tangent and the normal to the curve y equals to x cubed minus 2x squared plus x minus 2 at a point when x equals to 2. Let us begin with the equation of the tangent. We know that for us to find the equation of the tangent, we need the gradient of the tangent. And the gradient of the tangent is the same as the gradient of the curve at the point when x is 2. So let us get the gradient of the curve at the point x equals to 2. For us to find the gradient of the curve, we need the gradient function of the curve. That means we differentiate the given equation of the curve. Thus, the y dx here becomes 3x squared minus 4x plus 1. We have differentiated the equation of the curve. And this gives us now the gradient function of the curve. Now, for us to find the gradient of the curve, we substitute for x as 2. So, therefore, dy dx when x equals to 2 gives us here 3, x now is 2, squared minus 4 times x which is 2 plus 1. When we simplify this gives us, press the calculator, 12 minus 8 plus 1, something of 5. 2 squared times 3 minus 4 times 2 plus 1. Yes, it is 5. This is the gradient of the curve at the point x is 2. This is the point of tangency. Remember this point when x is 2 is a common point to the curve, to the tangent, and to the normal. So, we say that at the point of tangency 2 in this case, the gradient of the curve is the same as the gradient of the tangent. Therefore, this is the gradient of the tangent. Remember, I'm not saying that at the point of tangency, the gradient of the curve is the same as the gradient of the normal. No. It is only at the point of tangency, the gradient of the curve is equal to the gradient of the tangent. Now, if you know the gradient of the tangent, which is a line, and you know the x value, okay, and you know the x value of the point, that means we can find the equation. Why? Because when x is 2, when x equals to 2, this is the x-intercept. It implies that y equals to 0. So the coordinates of the point x equals to 2 are 2 and 0. So we have the gradient of the tangent and the point through which the tangent passes. So this is x, this is y. We can now go on to find the equation of the tangent. The tangent is a line, therefore y equals to mx plus c. Then we substitute. This is x, that is y. So we substitute for y is 0, equals to m. M is 5 times x which is 2 plus c. You know that c is a y-intercept. So from here we make c the subject of the formula. So c is negative 10. After getting c, substitute for m and c and we get the equation. Therefore, the equation of the tangent becomes y equals to 5x minus 10. That is the equation of the tangent. Now let us go to getting the equation of the normal. So say equation of the normal, What do we know? We know that the normal is perpendicular to the tangent. So NB, the normal is perpendicular to the tangent. Now what does mean? What does that mean? We have said that if two lines are perpendicular, then the product of their gradients is -1. That implies that the gradient of the first line m1 times the gradient of the second line m2 equals to -1. So let me call the gradient of the tangent m1. So we substitute here for m1, which is 5, times m2 equals to -1. Therefore, m2 equals to -1 out of 5. This is now the gradient of the normal. Now, if we know the gradient of the normal and we know the point through which the normal passes, we can get the equation of the normal. We have said that when x is 2, y is 0. So, the coordinates of that point are going to be 2 and 0. And this is the gradient of the normal, -1 out of 5. A normal is a line, therefore y equals mx plus c. Now let us get c, where c is the y-intercept. So we substitute, this is x, this is y. We substitute for x, y, m, find c. Y is 0 equals m is -1 out of 5. X is 2 plus c. That means if we make c the subject of the formula, c becomes 2 out of 5. After getting c, we substitute for m and c only. Therefore, the equation of the normal becomes y equals to -1 out of 5 x plus c, which is 2 out of 5. And this is the solution to example 3.